spaceship has achieved terminal velocity at an altitude of 3,500 meters above Mars' surface. What force will be required in order for the spaceship to come to a stop exactly at surface level? So the rocket is firing off, but normally we think of a rocket firing off, pushing it away from a planetary body. What's happening now is that it's going towards the planetary body and it's shooting, it's using its propulsion system to stop instead of takeoff. So we need to think of two forces here. First, we need to counteract the force of gravity, which is mass times acceleration. The second thing we're going to have to do is stop it from moving. Let's figure out the force of gravity first. So the mass is 3,800,000 kilograms right here. So just to counteract the force of gravity, 3,800,000 kilograms. Also, we need to know the gravity on Mars, which is 3.7 meters per second squared. We can't just use 10 here because that's Earth, right? All right, so 3.7 meters per second squared. Let's multiply those two out. And we will get 3,800,000 multiplied by 3.7. And that's going to be 14 million. Force of gravity on the rocket is going to be 14 million. And there's actually a 6 here. So there we go. 14,060,000. So there we go. Newtons. Just to counteract gravity. That's not even to stop it. That's just to keep it from accelerating downwards. Now let's find, let's call the force 2, or the force to stop the rocket from moving. So right here just allows us to stop from accelerating downwards. The second one is actually going to stop the rocket from moving. So what is that force? We know that it goes from 300 meters per second downwards to 0 meters per second. And we also know that it took 3,000 meters to do that, or we have 3,000 meters to do that. So let's go ahead and set up a kinematics equation to find the acceleration. And then, because here we can find that we have the acceleration. We get 3.7. But for the rocket actually stopping, we don't know how fast it's stopping. So let's go ahead and look for that now. So X initial should be 3,500. X final, what is that? That's going to be 0 meters, right? Velocity initial should be negative 300 meters per second. Velocity final should be 0 meters per second. Acceleration, that's what we're trying to find. And time, we don't know that either. So, let's highlight the one that we want to know but we don't know, which is this one. And then let's get rid of the one that we don't know and we don't want to know. So we want to exclude this from the equation, because we don't know it and we don't want to know it. Okay, so how do we exclude that from the equation? Well, we just look here for the variable that's missing, and then t, we want t to be missing. So big 5, number 5 is the choice. Okay. So v squared equals VO squared plus 2 times A x minus x0. Now we just plug in all these values and we should get the answer. So v squared, that's 0 squared, equals velocity 0 squared, so negative 300 squared, plus 2 times A x minus x0. So that's 0 minus 3,500. And then remember, this is x final right there, that x final. And we need to know, we already know that x final is 0. Okay, so that's going to be 0, 300 times 300. What is that going to be? That's going to be 90,000. Plus 2 times A, or that's going to be this 2 multiplied by the negative 3,500. That's going to be negative 7,000 A. Let's subtract or add 7,008 on both sides. And we end up with 7,000 A equals 90,000. Let's go ahead and divide by 7,000 on both sides. And A, 90,000 divided by 7,000, that's going to be 12.85. Or maybe 12.86 actually. Well, let's just use 3 significant digits. That's going to be 12.9 meters per second squared. Okay, so that's the acceleration. Now we just need to find the force. So the force to stop the rocket. So we already put force to stop the rocket from accelerating downwards. Now we just need to take off that speed. So mass is 3,800,000 multiplied by the acceleration, which is 12.9. And that's going to be $48, or about 49, or 489. And then let's see how many zeros we get. 5 zeros. 1, 2, 3, 4, 5. So that means we get 48,900,000 newtons. Okay, so if we add these two together, this one and this one, we should have the answer. So force total equals $48,900,000. All right, let's go ahead and add those two together. 48,900,000 and 14,060,000. Add these zeros together. Okay, 0, 0, 0, 0. 0 plus 6 is 6. 9 plus 0 is 9. And then 8 plus 2. 8 plus 4 is 12. And then we get 4, 5, 6. So 62,962,000 newtons. 62,960,000 newtons is the total force that the rocket has to push. Okay, so let's talk about why is this an addition sign? Why is that there? So let's imagine that there's a rocket and it is falling. Okay. So you have two forces acting on it if it's coming to a stop. The force of gravity is pulling down, so you need to have an equal force acting on that. You need to have something equal to the magnitude of the force of gravity pushing up. Then you need to stop the thing. So that force is also going to be in this direction. So this thing is falling. This rocket ship is falling, right? So you also need a force to stop it from going 300 meters per second all the way down to 0. So that force is going to be up too. So if we have this force pushing up against gravity and we have this force to actually stop it, then those forces get added together and they're positives because they're pushing up.